Hello and welcome everyone. In this video, we are going to talk about demand paging. So the demand paging means that the pages should be brought from secondary memory to the main memory only when the process demands it. Okay. So let's say you have a secondary memory and then you have the main memory and you have process A and process B. So let's say when the process demands the page, then those pages can be swapped in and we can swap out the pages that we don't need at that point. Okay. So instead of swapping the entire process into the memory, only those pages demanded by the process are swapped from secondary memory into the main memory. And this is also often referred as lazy evaluation. Okay. So how is the demand paging implemented? Well, when a process tries to access a page, there are certain steps that are generally followed. First, it will try to attempt to access the page. Okay. If the page is valid, which means it is there in the main memory, then it will continue to process the execution as normal. So if the page is already present in the main memory, then no problem, it can continue the execution. Okay. However, if the page is not present in the main memory, then it's going to request for that page. So if there is not enough space available, then it has to go for swap out and swap in. If there was enough space available, let's say there were only 2 pages here and then the rest of the 2 frames were empty, then you could have directly requested that particular page from the secondary memory and bring that into the main memory. But let's say all the frames are already full. So in that case, it has to swap out something. So let's say we have a P4 over here. It's going to swap out the P4 and then it's going to bring in the other page that the system needs. Okay, so if system is requesting a particular page, it has to bring that in, and to make room over here for that page to come in, it needs to swap out the page that is currently not being used. Okay, now in case if the process requests for a page and it's not there in the main memory, this is called page fault. Okay, so and you can say that, so if the page is invalid, then page fault trap occurs. It also checks if the memory reference is a valid reference to a location in secondary memory. If not, then the process is terminated, called legal memory access. Otherwise, we have to page in the required page. So that's all about the demand paging, which in a nutshell is basically saying that bring the page into the main memory only when the process demands it, don't bring it otherwise.